Hey there, got a question on doing some linear correlation here. So I wanted to take a moment just to make sure that was something that we understood. So the whole concept of linear correlation is that you take real data and try to model what's going on so that you could predict the future. And so the first thing we want to do is we want to plot all these points. So they represent, years since the year 2000. And it looks like it goes all the way to 16 years later, which would be 2016. So all these other ones are like 2002 and 2004 and 2006. So these represent different times in the study. And then on the other side, you're looking at, the number of CDs sold. Now, a lot of people don't even really remember CDs anymore because they're not used as much. People are downloading stuff off the internet, but it used to be a big thing. And so if you notice these numbers, 13,000 sold, then 12,000 sold, then 11,000, 9,000, 5,000, they're really trending in the negative direction. And so you would take time to kind of plot these points out, and I'll try to do that just as an approximation here. 13,000 is your y-intercept, 13,000. 215, and then 2 years later it looks like you're hitting 12,000, so I'm assuming these are going by twos. Yeah, just making sure. And then at 2 years later, you are already at 11,4, so that's about here. And then 9,3, 2 years later, so that's below 10,000. We'll say it's about there. And then 8 years later, that's two more in the future, I'm at 5,400. So I have to scroll down a little more, I think. 5,400, let's say that's somewhere in here. 5,400, yeah. And then 10, you're at 33. So I just want to double check my axis here. Yeah, so 33. Definitely trending in the negative direction, it feels like, getting smaller and smaller as time goes on. At 12, you're at 2,400, so let's just say that's about here. And it's an approximation again. Hopefully you don't get too bogged down by like the exact point, as long as it's close to, between the right, grid points for that particular value. And then at 16, you're at 1,100. So this line is 1,000, so just a little bit above it. Okay, so the next part you'd really want to do is you'd want to take time to put these all in a graphing calculator, because the whole point of using linear correlation is that you use basically technology to give you an average line of best fit. So you could try to do it, here where you're trying to say, okay, what line really kind of represents the best, way to, represent what's going on average, And so it can kind of be hard to do that just by, by hand. And so we've come up with different strategies for doing that. But the best way to do it in the Algebra 1 level is to learn how to use a piece of technology like in the TI-84 graphing calculator, for instance. This is my favorite calculator to use for high school math, even college math. Stat edit allows you to go, I'll do that one more time just so that everybody sees how to get to that part of the screen. If you were to press stat and then go to edit, you can basically provide the calculator a table of values or even just one list of values. In this case we have two sets of values. So the first column is going to represent years since 2000. Now again, I just want to represent values like 0 for the year 2000 because I'm trying to start it at the origin. You don't want to have the input as 2000. That really makes the equation crazy far to the right as your starting point, and it just kind of makes the math thrown off a little bit from some of the context of what's going on. So I'll explain that in just a minute. So once you give whatever piece of technology you're using, in fact, there's other websites you could do, linear correlation calculator is what I'm looking for, linear correlation calculator. And you do want one that's going to give you the correlation coefficient. I'll talk a little bit about that later, but there are other places on the internet you could use if you don't have this exact calculator to, support your learning on it. But let me go back to the table so I can finish putting in like the CD count for each year. So I've got 13,215. I will say as I'm doing this, you want to make sure that you type in each value exactly, because if you do not, you are going to be changing the data unintentionally, but you will be changing the outcome of your formula because the data is not accurate. So as you're typing them in, always just double check. I'll probably mess one up now that I'm sitting here talking about it. Just always be conscious of that, because that's something that it's a lot of input. You are pushing a lot of numbers, and if one of them is wrong, then your formula is wrong. So, all right, and the last one, 1172. All right, so once you have all the data in there, all these calculators have certain features that you have to understand. So stat edit is where you build the table. If you go right, you can calculate different things with the data that you input there. I'm looking for a line. This is called linear regression. So regression just basically means I want to come up with an equation that best models the points from a study so that you could maybe predict what the future would be, or maybe points in between. That's the concept of interpolation and extrapolation. But I want to go to linear regression. It's using those lists 1 and 2 for my x and y, my input and output. You can even have it store, if you go to variables, y variables, and then under function y1, you can have it basically store your answer in the graphing feature, which I'll show in a minute. But here we go, we're calculating our linear correlation, and this is basically giving us a line of best fit. It looks like the equation, I'll just type it over here, it's like y equals, pull that back up, negative 85.6. Oh, it's not going to let me type at the same time. I don't know. I've already got it typed on the other screen, so let's just jump to that. So basically, they're giving you that equation, and I will bring the calculator back up so that we can see exactly what I'm saying about that. If you notice, you're in the linear chapter here, so y equals mx plus b is really dominating the conversation about how to build the equations. And when we're looking at these values, it's asking us to calculate that equation, that function that really represents this whole idea of number of CDs sold over time, and then graph your answer and all that stuff. And so we've got an mx plus b here of negative 856. So basically what that means is that's how much it's going down each year. That's called your rate of change. And that first number is basically an approximate of kind of where you started. If you remember your first point in 2000, it was 13,215 CDs sold. That number is not exact, and that's because, again, the other points are really, throwing themselves into the average, and so that value really represents what's called the y-intercept. But then this value here again represents the rate of change, meaning you're going down that many CDs on average per year. So to graph it, we've got our points that I had on the other page, and then you've got that line of best fit, basically starting at 13,000 as your y-intercept, and then going down 856 and over 1. So bringing back the calculator, you want to have some way to calculate what's called the correlation coefficient. So the correlation coefficient is basically a value that shows how close those points are to each other. So sometimes you don't have very strong correlation, meaning those points that are in your study aren't in a nice line going down. Like this is a pretty linear trend. Like if you had a few years where it went back up and then back down or something like that, or if you had it just kind of all over the place, there's not much of a correlation that you can draw from it, meaning that the line that you have, it's not really a good predictor of it. But for this one, this is a pretty strong correlation coefficient. That number again is from the calculator, that R equals negative 0.97. So it's negative just because the slope is negative. But more importantly, that number is, in my mind, I think of it as like 97% accurate. 97% of the time, it can give you a value like within reason of what it was, in the study. So that means that it's a very, accurate equation. You could really use it. It's a good model. It's a good equation to really predict what's going on if you wanted to think about future trends. For this one, it's about to just be 0 because they're not going to sell them at all, and that is probably what happened eventually. So the last part is using your values for certain years. So like 2007, 2007 would have been basically when x is 7. And so it's good to have, that calculator feature where you can store the equation in there. I may mess with my window for a second because I want to be able to show all of the points. You started at negative 13,000. Let's just make it negative 14,000. And we'll go all the way to 0. I put 14. Alright. Messed up. 1 second. Messed up my window somehow with the negatives. Yeah. I wanted this to be positive to 0. Oh, but that's the minimum. Okay, so I want the minimum to be 0, and I want the maximum to be 14,000. There we go. Thanks for being patient. All right, so here is that line, and really, since I put all those points in, what's great about the TI-84 calculator is I could just turn the plot on, and basically all the points that I just plotted would also be there, and you can kind of see how close those points were to the line of best fit. Okay, so again, it's pretty close, and that's why I'm getting 0.97 for that correlation. Now again, this part is very common in questions where they're asking you to say, well, what do you use the line of best fit to predict a certain year? Well, if you have the equation in here, you can just input 7. Sorry, you got to press trace first. 7. Oh, it's not letting me do that. Maybe it's because I got the plot on. Let me turn the plot off. If you use a TI-84, you understand what I'm talking about here. Sometimes it's kind of finicky with... Alright, there we go. So once I have the equation, I can say, okay, let's plug in 7 for the 2007 year. And if you notice, you get 7570, kind of estimated there. They wanted us to predict a few other years. They wanted us to do 2015, so that'd be when x is 15. Looks like it's around 721. And then 25, well, that's way in the future. That may even be when it's negative. Let's use the table feature to just go to when x is 25. I had to change my window. That's why it didn't like that. I had a window that was closed. So it looks like I went too far because it's lagging. I'm doing the video. Basically, you get negative 7,838. And that's because basically it's predicted by 2025 that you won't be selling CDs anymore. The technology have changed. All right, well, hopefully that was helpful. Let me know if there's any questions, and yeah, see you next time.